In mathematics, groups and coding theory is a very important topic. So today we start with some topics from groups and coding theory. Now the first unit is integers. Now see what is the meaning of partition. So partition is nothing but actually division into parts. Now in mathematics, see what is the meaning of partition of a set. So a partition of a set A is a collection of non-empty disjoint subsets of A whose union is A. Or for any set A, subsets AI of A is a partition of set A if first is A equal to A1 union A2 union AN. Secondly, AI intersection AJ is phi for any I not equal to J, means distinct subsets are disjoint, and third is AI is non-empty for any I. See, what is the meaning of partition of set A? So we are dividing the set A into its non-empty subsets whose union is completely A, and if you consider any two different subsets of A, then no element is common. So such type of collection of subsets of A is called as the partition of that set A. Now see this example. Suppose this is the set A. So here we are dividing A into 5 subsets. This is A1, A2, A3, A4 and A5. Now each is a non-empty set. Then A1 union A2 union A3 union A4 union A5 is equal to A. And if you consider any two distinct subsets of A like A1 A2 A1 A3 A2 A3 A2 A4, then no element is common. So such a collection is known as partition of that set. Now see this set A is equal to 1 2 3 4 5 6 7 8. Now, if you consider the sets 1, 2, 3, 4, 5, 6, 8, 7. Now, all these 4 are subsets of A. All are non-empty. Then union of 1, 2, 3, singleton 4, 5, 6, 8, singleton 7 is nothing but 1, 2, 3, 4, 5, 6, 7, 8 means entire set A. Then see, there is nothing common in these two sets. Similarly, if you consider 1, 2, 3 and 5, 6, 8, their intersection is an empty set. 1, 2, 3, 7, again intersection is empty. 4, 5, 6, 8, intersection is empty. 4, 7, intersection is empty. And 5, 6, 8 together with singleton 7, again it is empty. Means they are pairwise disjoint. Their union is A and all are non-empty. Hence, this collection forms a partition of set A. Now, there is another partition. Say, first, if I consider 1, 2, 3, 4, and another set is suppose 5, 6, 7, 8. Then again, both are non-empty subsets of A which are disjoint and their union is A. So, in this way, for the given set A, you can define many such partitions. For a set of integers, singleton 0, then positive integer or natural number set, and negative integers. These three sets constitutes a partition of Z. Now, see, this is one important theorem regarding equivalence classes. The equivalence classes of an equivalence relation on a set A constitute a partition of A. Conversely, for any partition P of A, there is an equivalence relation on A whose equivalence classes are the elements of P. So, if you consider any equivalence relation on set A, then the corresponding equivalence are pairwise disjoint, they are non-empty, and their union is A. So they constitute a partition of A. In reverse way, if there is some partition P of A, then for that partition, one equivalence relation is associated with it, whose equivalence classes are the elements of B. Now, next example is find all congruence classes of Z modulo 4. Now already we have seen the definition of congruence classes of Z modulo n. Now we consider x as any integer. Now if we divide x by 4, then the possible values of remainders are 0, 1, 2, 3. So for these values only we decide the congruence classes or equivalence classes, because for remaining elements we get identical equivalence classes. Now to find a congruence class corresponding to 0, by previous part, congruence class of 0, which is 0 bar, is equal to x in z such that x is congruent to 0 modulo 4. That means 4 divides x. So x is equal to 0 plus 4k, where k is an integer. So for k is 0, 1, 2, 3 and so on, the set contains 0, 4, 8, 12 and so on, minus 4, minus 8 and so on. So this is the congruence class corresponding to 0. Similarly, for congruence class corresponding to 1, it is x in z such that x is congruent to 1 modulo 4, means 4 divides x minus 1. So x is 1 plus 4k. Again, by taking the different values of k as an integer, we get this as congruence class corresponding to 1. Similarly, we can find 2 and for 3. If you consider again for next number, that is 4, then we get it as same as 0. Again for 5, same as 1. For 6, same as 2, like that. So the residue classes so form partition the set of integers. See, if you consider union of 0, 1, union of 0 with congruence class corresponding to 1 together with 2 and 3, then union of these 4 sets is equal to entire set Z. Then all these 4 sets are non-empty. And if you consider distinct congruence classes, then they are disjoint. So for these 2 sets, no element is common. Again for first, third, nothing is common. Same way for first, fourth, second, third, second, fourth and third, fourth. So they are pairwise disjoint, and hence these residue classes form a partition. Now similar to this, for modulo 4, for any natural number n, the set of congruence classes, that is residue classes modulo n, is denoted by Zn, and it contains the elements 0 bar, 1 bar, 2 bar and so on, n minus 1 bar. Similar to previous example, here we have to find all congruence classes of Z modulo 6. As it is modulo 6, see what are the remainders when you divide an integer by 6. The possible values of remainders are 0, 1, 2, 3, 4, 5. So it is enough to find the congruence classes for 0, 1, 2, 3, 4 and 5. Now see, to find congruence class corresponding to 0. Again, similar to previous example, it is x in z such that x is congruent to 0 modulo 6. It means 6 divides x minus 0. So x is equal to 6 into k. So by taking different values to k, we get congruence class is equal to 0, 6, 12, minus 6, minus 12 and so on. Similarly, we can find congruence class corresponding to 1, 2, 3, 4 and 5. So finally, this is the set of congruence classes modulo 6, which is 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar. So this is the end of unit 1.